and welcome to another episode of Circular Insights. My name is Lijin, and I will be your host for today. I'm really happy to be sat with a very special guest from Sushui Energy Technology Shanghai today, which is Daniel Low, the co-founder, board member, and business development director of Sushui Tech. Daniel has more than 10 years experience of the renewable energy sector, and today we're going to be learning about direct methanol fuel cells, which is a key product of Sushui Tech as an independent power solution for Internet of Things and critical missions. Now, those probably are quite big words for most of the audience out there. So I'll leave it to Daniel to then explain a little bit more about what is this critical missions and also how this independent power solution is really solving a very important part of our transition into a more sustainable economic model, a more circular economic model. Welcome, Daniel, to our podcast.
Thank you, Lijin, for inviting me to your podcast, and hello to the audience. And first of all, although you said many big words, actually we are solving small problems and very critical small problems. Like imagine that you have critical assets in a remote area, like mining site or environmental sensors, and there must be problems how to provide power for these applications. And we know that we have a huge scale of PV power plant that might generate megawatts of power that can work independently. And we also know that we have a wind turbine that also can work independently, offering like several kilowatt power. But there is no solution, no reliable solution for power consumption range from like 50 to 100 and 200 power consumption. There's no such a reliable solution. So what we are solving is to provide a reliable solution for these kind of applications. And also our solution is renewable and green.
Thanks very much, Daniela. And maybe you can explain to the audience who are maybe not that familiar to that range of the power that's utilized. What sort of devices, apart from what you mentioned, it's in mining sites, it is environmental monitoring. What sort of devices would require that range that you just talked about, which is not something that the large solar independent plants or the large turbine independent plants would be able to cover?
Most of them are surveillance and also communication devices for remote areas. It's different from what we have in the urban areas. In those areas, the communication doesn't have so much users, so the power consumption is quite low, and they need power around 100 watt to provide for their base stations and also for their cameras and also other sensors that take noise and voice signals, and also the weather conditions, like those kind of applications. And sometimes this application, although they require very low power, but they is critical to the client's applications. For example, if you lost the data of wind measurement radar, the owner will not be able to get a loan from the bank, so the project will not be continued. And for mining sets, if there's anything happen to the surveillance camera, if there's a power out, the thief or some other things, the entire working site will broken down. There will be a huge downtime, generating huge costs that is not acceptable for the owners.
So when you describe it that way, it sort of prompts me to think of other examples where it could be deployed as well. I seem to recall you did mention things even along this, the lines of like let's say there were critical sort of monitorings for avalanches or even natural disasters or wildfires. These would be the types of devices that you would be talking about as well. Is that correct?
Yes, exactly. In the past, the avalanche is not such a big problem for big projects and even for tourism. But nowadays, because the global warming and the avalanche becomes it happens more frequently and more fierce because the snow is accumulating in big amount on the mountains, but the snow line is keeping raising. So when it crumbles down, it will destroy more lands, more villages, and more people. So last year we took a project in Tibet. We already had a very big avalanche monitoring system in the region, but the problem is that during the winter, when the temperature drops to like -40 or -50 Celsius degree, and especially on that high altitudes, the entire network just broken down. It doesn't work. So the owner, the administration found us to provide a compact and reliable power solution for them. After that, since the end of last year, our fuel cell worked well for the system, and all avalanches were forecast 3 days in advance, and there's no one injured until now. Yes.
Wow, that's an amazing impact. I mean, I can definitely feel those type of emotions, especially if you thought like your community would be safe from those whatever disasters that these early monitoring detection systems would sort of warn us, or early warning systems would tell us about, regardless of whether it's avalanches or maybe in some other parts of the world, it's typhoons, hurricanes, tsunamis, etc., or even flooding, right? If those
Sure.
systems were in place, and then to suddenly realize that the systems weren't actually on because the power was off. I mean, as the community that suffered, I mean, it would be devastating because you had that opportunity to avoid a very bad consequence, a very bad
Sure.
outcome
Yes, yes,
if the
exactly. Yes,
power was on.
yes, we are very proud of what we did in Tibet, because when you were in the mountains, you see very magnificent scenarios around you, and what you do is helping people there to keep their life normal. That is very stirring up or sense of proud.
Yeah. And I really like that point that you raised there, that maybe in the past it wasn't going to be as bad as effect. But as we switch into a more sort of volatile climate system, there's more
Mhm.
unpredictable climate or weather conditions that we would be facing. These early warning systems needing to be online is going to become so
Yes.
critical, because it also affects things like, even when you said critical assets, I'm guessing, and you can correct me, it also includes things like hospitals. It includes things like there's even the disaster relief areas where they need power to stay online. Is that correct?
Yes, correct, correct. Actually, there's also application to safeguard the road. Uh, for example, one of our fuel cell is deployed to a road that is the only road leading to a county inside the mountains. So when the avalanche come, we need to warn the travelers before the disaster happen, so they can store enough supplies in the town, so that there won't be any starving, or they will have enough medicines and supplies.
Wow, that's amazing. So, in terms of the deployment of your technology, it seems like there are multiple areas that there would have like real life impact on. Apart from the corporate part, which is you're protecting the business assets that's deployed in these remote places, like mines or big construction sites that have not yet been
Mm.
connected, or even then there's the environmental monitoring parts of it, early warning systems. Is there another section that you are deploying your technology to?
Also, we can deploy in the urban areas. For example, we integrate it with on a trailer together with PV panels, and it will supply power for cameras that prevents crime.
Wow. Wow. So from a security perspective as well,
Mhm.
that
Yes.
also can be deployed.
Yes. Because if you are only using a PV panel with lithium batteries, you will need a big capacity to bridge those bad weathers, and also maybe it will also generate a big cost of logistics. The one of the merits of a product, the MFC, is that it has a very huge energy density. It stores like 1 kilowatt hour energy by 1 kilogram. So if we are using lithium batteries, it will be like 14 kilograms. That's a very huge difference. So by replacing lithium batteries in partially with methanol, the entire costs of logistics will be cut down.
Wow. And I think at this juncture, probably we want to actually understand, is this direct methanol fuel cell? Because fuel cell, I would believe, is a power generation, but what you described
Yes.
just now is a battery usage scenario. So for the
Mm.
audience who's not very familiar with this technology, Daniel, do you mind explaining a little bit about, is it actually a battery or is it actually a power source in its own?
Theoretically, it is similar to batteries. All batteries, they have a membrane inside to divide the anode with a cathode, and also it is the same for fuel cells. But the difference is that the fuel cell take the reaction materials from outside, not in a concealed environment like battery. For a battery, you need to store enough reactants inside like a box or a container. But for fuel cell, we can take methanol from outside. We can build a big volume of container as big as you want to store enough methanol to store enough energy for you. And as long as there is methanol, the fuel cell will keep running to provide power for you.
So therefore, when we're talking about the direct methanol fuel cell that can be sort of moved to all these different remote places, and that does it also require that movement of methanol to those places, or is the Sushui tech something that is able to generate that methanol using whatever is on site?
In the future, yes, we are heading for that direction in the future, because one of reason for my choice on direct metal fuel cell is that I believe in methanol economy. In the future, we can generate methanol everywhere, from plants, from vegetables, from everything, even from waste from the farmlands. But for now, we are only focusing a small link on the whole methanol economy. So we only focusing on the power generation from methanol for the moment.
Right. Thanks very much for that clarification, Danielle. So I guess the next question would be like, obviously we know there is that power related pains that is being faced by different systems of that certain size of energy that they need. But what actually prompted Sushui Tech and yourself actually to pursue this journey to solve this pain? I know you mentioned just now you believe in the methanol economy. What prompted that?
And when I was in college, I read a book about the decentralized economy. One of the key factor for decentralized economy is decentralized energy system. For example, in the future, we can have a vision like each community has its own water power plant, their own PV power plant, and also own wind farm. But considering all that, given all that, we still need a fuel that can keep our automobiles and mobility applications running. That is how we carry energy along with us.
Mm.
So I think since that time, I think the methanol is a very good option, because methanol can be generated everywhere as long as you have farmland, as long as your cattle have your stock livestock, you will be able to get a source of methanol. It's just a technological thing. So I started my journey from PV industry because in that time, just after my graduation, there was no enough technology resources for direct metal fuel cell and also other fuel cell technology. And after several years, when I was in India, I worked in India. I see that there's a technology from Germany. It's called direct metal fuel cell. Since that time, I kept looking for the same technology in China. And luckily, I found Dr. Sophie. She's also our founder. I read an article about her. She invented her own MEA, which is the core material for this kind of technology. It's called membrane electrode assembly. So I found her, and together we agreed on we can make a business and we can contribute to the energy future together.
And on that note, I would like to let the audience know that Sushui Tech is just one of two providers worldwide for direct methanol fuel cells at this point in time, which is quite an amazing feat. And there has been a lot of research and development that's been happening from Dr. Sophie's front before we actually see this commercialization of the product itself. Yeah.
Yeah, still it took us a lot of time, and our company was founded like in 2017, and it took like 6 to 7 years for us to commercialize this technology because uh, uh, only MEA and only the core material cannot generate any power. It's not user friendly for the end customers. We have to build into a stack. We have to integrate it stack into the whole generator system. So it's really a hell lot of work.
Thank you for putting in the work. Yeah, and with
Mm,
that, I guess like another question that just sort of pops up in my mind is that
mm,
I mean, from the examples that you mentioned just now, it seems like the direct methanol fuel cells can work together with solar panels, can work together with other renewable energy related things.
mm.
Is it meant to be complementary, or is it meant to be like replacing out, these more expensive sources of renewable energy?
In the future, we believe there will be a common ground for all energy. It
Mm,
might be nuclear energy, it might be some kind of energy, but for the moment, I think methanol is the best soil for future renewable energy to grow on. First of all, we can get methanol from solar power and wind farms to make to sing to mixture carbon dioxide with green hydrogen together to make a methanol, and to consume methanol to generate it into power. We can use combustion engine, which is not ideal, but is already commercialized. We can also use a fuel cell like a direct metal fuel cell for small power applications like security, environmental monitoring applications. We can also there's also a tech path is called reformed methanol fuel cell. It can reform methanol into hydrogen again and use hydrogen to power a hydrogen fuel cell. It has a bigger power generation. It can power up bigger applications like automobiles and even small power plant, a small community. Maybe I think in 5 years or 10 years there will be multiple technology paths working together to share different sector of the market, but
mm.
they have a common ground. There it is best to be methanol. Mhm.
Right. So if I understand it correctly, is that anyone who is actually out there thinking that, oh, this is going to be the one all be all sort of energy solution out there, unfortunately, that's not going to be the case. But
Mhm.
every part of the technologies that's being developed, regardless of whether it is in solar or in methanol or
Mhm.
in wind or nuclear. It all plays a different role in the sort of mixture that energy that we need for our economy, but also for the society, because we all come in sort of different shapes and sizes. Some require higher energy outputs, some require smaller energy outputs. For different types of devices, you would require different type of energy levels. I mean, just imagine putting in a plug point into something that's going to like blow your plug socket because it's got so much
Exactly.
power. It's not going to work, right? So we actually have to
Yes.
have that matching of the right level of energy to the right
Mhm.
level of usage and needs.
Yes, it also maybe in the future it depends on the people's attitude to their lifestyles. You can choose to live on grid or choose to live off grid. When you choose to live on grid, you will have wired internet, wired power supply from a very big power plant, which is also risky because once the grid is down, you will get run out of power. You have no power to live on. And also you can choose to live on off-grid. You have your own power supply, you have your own generators, and you will have like a wireless communication devices. You can recycle your daily wastes into power again, and you can get energy from what you consumed. That's a far vision of a company.
So you're more in the sort of the off-grid, supporting the off-grid sort of realm.
Yes, yes. I think in the future, if everyone can take care, use the new renewable energy to take care of their own life, to take care of their own house, that will be the true renewable society.
So then it's not so, in a way, some people will say that, oh, that may be worse because everyone will have like too much control over their own space. But then some, it's also good in the sense that you have more diversity and more sort of built up buffer for, in any case, like if the grid were to actually break down, like what we saw in Texas, I think a few years ago, where it got frozen and literally the whole Texas was out of power for like 3
Mhm.
continuous days. And that meant like people actually did die in hospitals because they did not have power. They could not get that emergency power back on. People who are on like critical care could not get those
Mhm.
devices to be turned on. Security related systems were off. Just thinking of all the transportation and logistical complications that would happen because everything on the roads was off. Apart from what's happening in the household, it's just amazingly, I mean, stark that could actually be a future where we're too reliant on a single grid.
Yes, yes, and even in the automobile sector is the same. We need to take oil and gas and oil from like gas stations, and we need to rely on international big business to supply this oil and gas resources. Uh, so somehow we cannot get true freedom. We cannot live on our own. We cannot be responsible for our own future. That is the problem.
Mm, mm. Right. So in terms of Sushi's current technology, I know you mentioned that the emissions is quite low already. Do you mind explaining to our audience how does Sushi actually achieve that type of, is it zero emissions or is much lower emissions, or yeah, what is that impact of using a direct methanol fuel cell?
It's actually it's not zero emission. It has some emission of carbon dioxide because we are using methanol.
Yep.
Methanol it contains carbon, and when in reaction it will produce carbon dioxide. It's a natural thing. But the thing is that methanol itself can be generated from renewable resources. Like we can catch carbon dioxide from the air that we already polluted and mix the carbon dioxide with green hydrogen, which is purely clean. And together we make methanol. And methanol is a liquid. It can be carried everywhere to use. It's in a big sense. Overall it's carbon neutral.
So, and it also has higher efficiency, as you mentioned earlier, the capacity of like storing the energy within per kilogram. Yeah.
Mhm.
Understand that. Okay, right. So like looking ahead, if you had a magic wand, what would you want most to happen in the coming few years?
Maybe I have like the most is that suddenly the whole world accepts methanol as is the main fluid, liquid fuel.
And just now you mentioned that there was something happening on the hydrogen side as well. So why methanol? I guess that question.
Because methanol is liquid, and it will remain liquid form in a wide range of temperature, and it is quite safe. Although it's a hazardous liquid, it's safer than diesel and gasoline. And comparing to hydrogen, on the hydrogen side, it needs a compressed container or other solid ways to store it, but it will compromise the energy density.
Right. So in terms of like the logistical part of it, of storing, of
Mhm.
transporting, methanol has its advantages over the existing fuels of diesel and
Yes,
gasoline, being more safe, as well as for hydrogen, because of that sort of complexity of transportation, needing high pressure and things like that to
yes.
hold that hydrogen and transport it.
Exactly, and also, methanol is so widely used chemical material for like more than 100 years. It's well supplied in every country, and if you decide to go the path of methanol, the transformation will be painless.
Do you mind explaining that a little bit more? Why would it be painless?
Because you can get supplied immediately if you order. For example, in China, we order online. We can get methanol like even I'm in Xinjiang, even in the most remote place, so we can get methanol in 7 days. It will deliver to your doorstep.
Wow. And
Yeah.
because it's so widely accessible, it
Yes.
is not a new chemical. It is not something that human society is not familiar with utilizing. The supply is there. Um,
Exactly.
yeah. Okay. That's why it has its advantages of being a very existing alternative fuel compared to the existing of diesel or gasoline type of setup. No, actually,
Exactly.
diesel and gasoline is quite common. It's just that it's not as safe. That's what you actually were talking about just now, right? Yes.
Yes. Yes. Actually, in some gas stations in China, we can already inject methanol.
Really?
Yes, pure methanol. And
Oh,
it's
wow.
very cheap. And like in China, the cheapest price I got was 1.8 yuan per liter.
Wow. Wow. That's really low. Yeah. Yeah. Okay. So in that case, because like from where I'm from in Malaysia, there a lot of people actually do use diesel generators to
Mhm.
as backup power and things like that. In fact, a lot of our nature-based tourism sites as well use a lot of backup power with diesel generators and things like that. So how easy, I guess, is it to replace out that type of practice? They're really familiar with diesel generators. How easy would it be to then switch over to using a direct methanol fuel cell? Is it similar? Just
Uh,
pour in the thing, pull.
if we're talking about the future vision of a methanol economy, they don't necessarily need to change it to direct methanol fuel cell. And the best way to change the diesel generator is to use a methanol combustion engine, which is also commercialized in a very huge scale in China, and I think also in Brazil. This kind of combustion engine, although it's not that advanced as a fuel cell technology, but it is also, but it's already a good start for people to accept the methanol energy. They
Mm.
can use it for their automobiles and also for the power generations in big scale, like to provide like 100 kilowatt of power, which is already used in as a backup power for hospitals in China. It
Right.
will
So
generate.
just to
Mhm.
replace that combustion engine to be able to take methanol
Mm.
would be the start before even needing to
Yes.
switch over to a fuel cell type of range.
Yes. Yes, it is a start, but the problem is every combustion engine has upper limit of efficiency. It's the best efficiency is like around 40%.
Oh,
40%. That's where fuel cell technology start. Uh, For fuel cell technology, the efficiency can reach as high as more than 80%, like even up to 90%. So in the future, if everybody is already familiar with the methanol energy, we slowly switching the combustion engine into fuel cell technology, we can even make better use of methanol to save our energy, to save our environment.
yeah. So when we're talking about this from 40% efficiency up to 90%, um, in a way, you're making use, every unit of methanol that you put in will produce more
Mhm.
energy output that is usable for users than
Yes.
if they stayed with just a typical combustion engine.
Yes, yes. For example, the current state of the technology is that we convert 1 liter methanol into 1 kilowatt hour energy, but in the future it will be 1 liter methanol into 6 kilowatt hour energy.
Wow. So
Mhm.
then why go through the combustion engine then? Why not just jump straight into fuel cell technology then?
Because every technology has its pattern. It has its to develop through time. We need to invest in it to make people to accept it. We need to find a real profitable market and to let people accept it without force. We don't want to force our customers to accept the renewable generators or renewable technology only because it's renewable. We want to demonstrate this technology is profitable for their business. This technology is useful for their daily life and their applications that matters to them the most. Through that way, we can enlarge our market gradually, and the way we make it the market bigger is to spend the profit back into our product development and research. We can gradually increase the efficiency of our catalyst and also the membrane to increase the power density. And when it reaches a certain level, we will be able to replace combustion engine with fuel cell.
Right, right. So I'm very happy that you actually shared that because I think it speaks a lot about the value system and the approach that Sushui Tech is actually utilizing to find the right collaborators, the right clients who will be able to benefit from the technology, but also push forward the type of impact that you guys are aiming for. It's not just about, it's just not just about energy. Energy has a lot of repercussions, a lot of impacts on people's lives, as you rightly put
Yes,
there. And if there was that opportunity to actually change so many lives from the source of energy perspective, it's
yes.
really inspiring actually to hear how Sushui is actually approaching this whole challenge.
Yes, exactly. From the beginning, when we are talking or discussing our business or future vision with Dr. Sophie, we all agree that a beautiful vision for the future is necessary, but it is even more necessary to have a real market, to have a real profit, to make this vision come true.
Mm. And this really aligns with what Circular Business Association is often advocating, that sustainability that is not profitable is not sustainable. And that's why we are very much happy to be in that common journey with Sushui Tech to actually see how to bring sustainability further into that profitable realm. So it just becomes part and parcel of life, right? It's just, you have to just get on with your life. Everyone needs their livelihoods. Everyone needs a way to continue finding the resources that they need. And therefore, there's no, I like to use the word no shame, no shame
Yeah,
looking for
yes.
profits.
It's a natural thing. If you don't have profit, no one can live. It's a very simple thing.
Yeah. And even when we look into nature as well, it's not just about pure giving, everything takes, right? And regardless of whether
Exactly.
it's an exchange of nutrients or exchange of space or exchange of light or even exchange of chemicals, there is some form of mutual sort of exchange that happens in order for that relationship to continue existing. Even the ones that seem to be parasiting on others, they have a certain limit of which their type of organism can continue growing because they are dependent on each other. And I think that's the beauty of looking at it in the business realm as well. I think there's a community out there that probably believes that no profit should be on the table when you're talking about sustainability. But unfortunately, that lacks a certain degree of realism that in life is an exchange. There's always
Yes, life
something.
experience. Yes,
Yeah,
exactly.
life is an exchange. There's always something that we are exchanging. Yeah. So with that, this would be really interesting actually to hear about how your technology is being utilized in so many different places. And I know you guys are started off in Shanghai. You mentioned that you have deployed some projects in Tibet. Is China and or should I say Asia your main sort of target areas, or where is your technology sort of spread to so far?
Yeah, we now have a customer and market in Japan, in Singapore, and in Middle East like UAE, and also in UK. And actually, we get very good response from the market, and we got many potential customers from the entire Europe, because maybe in Europe the sense of renewable energy to offer circular economy is better than the rest of the world. And in China, it's more about it can solve problems in remote areas. Mhm.
Right. So are you looking to continue your global sort of like expansion then? And who would you be looking for? If there were people in the audience here who are listening to the podcast and getting to know your technology, who would be the ideal people you're looking for?
Sure. Just like we talked about the idea of a circular economy, we need to cooperate with each other to be profitable. We are also looking for partners and businesses that can provide maybe contribute in the same vision of a methanol economy in the future. Because although we have the vision, we only do a small part of it. And we want to cooperate with with people with same vision in the future. Maybe they do a big power generation, we do a small power generation, and maybe they consume power, consume energy. We provide for their applications, and we also if they can provide a good technology to increase or efficiency of a catalyst or core materials, that is, we are also would like to cooperate with them. Although we are a Chinese company, we would like to cooperate with different nationalities and different people from all around the world. And in the future, because we share this vision, it's a global thing. It's a it's a common for everybody.
Mm, mm.
Mhm.
So if I hear you correctly, you're looking for people who, of course, they are producers themselves of energy. Maybe then you would want to collaborate with these different energy producers of different scales, see
Mhm.
how your technology would be able to not only complement, but actually augment, I'll say, make even better each other's sort of energy related technologies. So that's the first group of
Exactly.
people who is out there. Also, the second group of people that you'd love to work with would be those businesses who maybe they have applications or devices that require your technology in order for their job to be done even better. Right. So
Yes,
all
exactly.
those early warning system people, all the security monitoring people, all the environmental monitoring, or even people in some remote rural areas serving communities there for telecommunications or whatever. Especially now with more and more Internet of Things devices coming on board, or what people I'd say smart devices coming on board, these would be businesses that you would like to work with as well.
Exactly.
And the third would be from the sort of core materials and to improve the processes of the technology itself. These would be the other group of people that you would love to be able to work with.
Yes, and also the suppliers of green methanol.
Oh yes, and suppliers of
Yeah.
green methanol. Yeah. Yeah. So when you talk about green methanol, it's actually two main components that you need, which is the carbon dioxide sources and the green hydrogen sources in order to create the green methanol. Is that correct? Or did I get that?
Correct.
Okay. Yes. Yeah, so although I have a science degree, it's been a while since I utilized fully my science mind. So bear with me, and hopefully in the audience that question was helpful for those of you who are also not that science inclined, to understand the importance of this technology and why I'm really excited to have this conversation with Daniel, because very often people think like, oh, we have the tech, right? But then they forget that fundamental thing, that tech needs to run on something. You need to feed the tech something, right? And what is that something makes a big difference, right? So it's I guess in an analogy, it's just like all humans need to eat, but what we eat is what makes the difference, right? So drawing parallels to even the agriculture sector, people would be saying that, we need to feed the world, and that's why we use synthetic pesticides and fertilizers to have created so much food in the world so that we can feed the world. But unfortunately, the way that mass agriculture has actually happened has depleted the fundamental base, which is the soil. And therefore, it makes it very difficult for that soil to actually continue to be productive. And it goes into this vicious cycle of then pumping even more synthetic fertilizers and even more synthetic pesticides in order to produce that food. So when we start talking about what people eat and how we are feeding people, it makes a big difference when we come down to that fundamental base of what is it that we are actually feeding people. So it's the same from technology. What is it that we're actually feeding the technology with? Even electrification, electric cars, where does that electricity come from becomes the fundamental question. And I'm really happy to have had this conversation with you, Daniel.
Thank you, Lijin.
Yeah. So we've come to the end of the podcast. Do you have any sort of final sort of remarks or a shout out to anybody who's out there listening and who would like to connect with you? And anything you'd like to share with them?
I would like to say to all the renewable energy sector that we need to make profit with renewable energy together. And that is I believe that is the only way we can make the future renewable.
Right. Thanks for that amazing closing statement. So if anyone would like to connect with Sushui Tech, in the descriptions, we will put down the website for Sushui Tech, where you can go look for them. I believe they're on LinkedIn as well. So it will be in the description as well, so that you would be able to easily find Sushui Tech if you would like to learn more from them or collaborate with them on various other projects. So once again, thank you very much, Daniel, for your time. It was great actually hearing about your technology and learning a lot more about this. Thank you also for bearing with some fundamental questions, because not all of us in the audience actually would have that very strong technical background. So thank you for your patience and willingness to really share those examples of how your technology is impacting business profits as well as impacting the world. Thank you, Daniel, and thank you everyone in the audience.
Bye.
I'll see you next time on Circular Insights.
See you next time.
Yeah. Bye.
Bye.